Saxon Algebra 1, Lesson 27. In this lesson, we will look again at the distributive property, and we will discuss simplifying decimal equations. The distributive property is the link between addition and multiplication. It is one of the most important properties in algebra, so we will first review it here. We looked at something like this in Lesson 17. Suppose a green rectangle measures 4 units by 2 units, and a red rectangle measures 4 units by 7 units. We put them together to form a larger rectangle. To find the area of that larger rectangle, we could multiply its length times its width. That's 4 times the quantity 2 plus 7, or 4 times 9, and we get 36. Or we could add the areas of the smaller rectangles. That's 4 times 2 for the rectangle on the left, plus 4 times 7 for the rectangle on the right, and that's 8 plus 28, which again gives 36. So there are two ways to simplify 4 times the quantity 2 plus 7. The parentheses indicate that we should do that first, so if we work out inside the parentheses, we have 4 times 9, which is 36. Or we can use the distributive property. We distribute the 4 over each of the terms in parentheses. 4 times 2 plus 4 times 7. That gives us 8 plus 28, which is again 36. Let's look at an algebraic example of the distributive property. We have 4p times the quantity x plus 3y. The 4p will be distributed over each term in the parentheses. So we have 4px plus 4py. Here are some more examples. Use the distributive property to expand. xy times the quantity y squared minus x squared z. The xy will be distributed over the terms in the parentheses. Notice we wrote those terms as addition. That's xy times y squared plus xy times negative x squared z. Now we will put the variables in alphabetical order and simplify. We have xy third minus x third yz. Another example, 4xy third times the quantity x fourth y minus 5x. We will distribute the 4xy third over the terms in parentheses. Notice again that we wrote the subtraction as addition of the opposite. We have 4xy third times x fourth y plus 4xy third times negative 5x. Let's be careful and rewrite the terms in alphabetical order with the coefficients in front. Then we have 4 times x fourth times y third times y plus 4 times negative 5 times x times y third. Do you see what was done here? When we simplify that, we end up with 4x fifth y fourth minus 20x squared y third. Another example, the quantity ay minus 4y fifth times 2x squared y. The 2x squared y is outside parentheses. That will be distributed over each term in the parentheses. So we have ay times 2x squared y plus negative 4y fifth times 2x squared y. Again, we will be careful and write the coefficients in front and then the variables in alphabetical order. That gives us 2 times a times x squared times y plus negative 4 times 2 times x squared times y fifth times y. Then we simplify that, and we have 2ax squared y squared minus 8x squared y sixth. Here's a slightly longer example. 8m squared x times the quantity 5m third x minus 3x fifth plus 2x. We will distribute the 8m squared x over each term in the parentheses. That gives us 8m squared x times 5m third x plus 8m squared x times negative 3x fifth plus 8m squared x times 2x. We'll bring the coefficients together, put the variables in alphabetical order, and simplify. That gives us 40m fifth x squared minus 24m squared x sixth plus 16m squared x squared. Now let's consider simplifying decimal equations. Finding the solutions of equations such as 0.4 plus 0.02m equals 4.6 and 0.002k plus 0.02 equals 4.02 can be made easier if we begin by multiplying every term on both sides of the equation by the power of 10 that will make every decimal coefficient an integer. The value of the smallest decimal number in the problem often determines whether we multiply by 10 or 100 or 1,000 or 10,000 and so forth. Example 1. We want to solve 0.4 plus 0.02m equals 4.6. The decimals can be a little confusing. The smallest decimal there is the 0.02. To change that to an integer, we can multiply it by 100 because that's 2 100ths. So we are going to multiply every term in this equation by 100. 100 times 0.4, 100 times 0.02m, and 100 times 4.6. 100 times 0.4 is 40, 100 times 0.02 is 2, and 100 times 4.6 is 460. So multiplying every term by 100 changes the equation to a much simpler one with whole numbers. Then we can solve that equation. We subtract 40 from both sides. That leaves us 2m is 420. And we divide by 2 to get m is 210. Example 2. 0.002k plus 0.02 equals 4.02. The smallest decimal there is the 0.002. That's 2 1,000ths. We can change that to a whole number if we multiply by 1,000. So we will multiply each term in this equation by 1,000. This gives us 2k plus 20 equals 4020. Again, a much simpler equation to solve. Now we solve it by subtracting 20. That leaves 2k equals 4,000. And then dividing by 2 to get k equals 2,000. This is the end of Lesson 27. Your assignment, problem set 27 on pages 115 and 116 of your book.